While one-point perspectives convincingly depict interior and exterior spaces, they may not effectively explain a three-dimensional form if the receding lines and planes which impart depth are not visible in the perspective view. Rotating the spectator's central axis of vision in relation to the subject transforms a one-point perspective into a two-point perspective. This reveals the three-dimensional form of an object in a more convincing manner. The pictorial effect of a two-point perspective varies with the spectator's relation to the subject. As the spectator moves closer to the subject, the vanishing points move closer together, horizontal angles become more acute, and perspective depth is exaggerated. As the spectator moves farther away from the subject, the vanishing points move farther apart, horizontal lines flatten out, and perspective depth is compressed. The height of the spectator relative to the subject determines whether the scene is seen from above, below, or within the spectator's own height. As the station point moves up or down, the horizon line moves up or down with it. Horizontal planes occurring at the spectator's eye level appear as lines. The spectator sees the tops of horizontal surfaces below the horizon line and the undersides of horizontal planes above. A common method of constructing a two-point perspective, also known as the office method, requires the use of two orthographic projections, a plan view and an elevation view. Begin by placing the plan of the subject directly above the space reserved for the perspective view. Orient the plan to the desired angle with the picture plane. This angle determines how much emphasis each of the major sets of vertical planes will receive in the perspective view. Establish the station point in the plan view. Check to ensure the major part of the subject falls within a 60-degree cone of vision and that the central axis of vision focuses on the center of interest. Locate the picture plane in the plan view perpendicular to the central axis of vision. The picture plane is typically located to pass through a significant vertical edge of the subject so that the edge can be used as a measuring line in the perspective view. The position of the picture plane affects the size of the perspective image. Moving the picture plane away from the station point enlarges the perspective image, while moving it closer to the station point reduces the size. Determine the vanishing points for the two major sets of vertical planes in the plan view by drawing sight lines from the station point parallel to the direction of each set until they intersect the picture plane. In the space directly below the plan view, tape the sheet of paper for the perspective drawing. Project the ground line from the elevation into the perspective view. Draw the horizon line above the ground line at a height equal to the height of the spectator's eye above the ground plane. The scale of the plan and elevation views establishes the scale of the picture plane in the perspective view. Project the two major vanishing points in the plan view down to meet the horizon line in the perspective view. These points are the vanishing points for horizontal lines in each major set of vertical planes. We can use any line coincident with the picture plane as a measuring line. A vertical measuring line therefore occurs where the corner of the gable form meets the picture plane. Project the position of the vertical measuring line from the plan view down to the perspective view. Transfer the true height of the corner from the elevation view to the perspective view. Project this height back in the perspective view by drawing horizontal receding lines to the left and right vanishing points. To locate the left and right corners of the gable form in the perspective view, project sight lines from the station point to those points in the plan view. Mark where these sight lines intersect the picture plane. Transfer these points down to the perspective view. In the plan view, project the ridge line of the gable forward to the picture plane to establish a vertical measuring line. Project this point down to the perspective view. Transfer the true height of the gable from the elevation view to the vertical measuring line in the perspective view. Project this true height back to the right vanishing point to define the ridge line in perspective. In the plan view, extend a sight line from the station point to the forward edge of the gable ridge. Project where this sight line intersects the picture plane down to the perspective view to establish the perspective location of the forward peak of the gable. We can draw the forward rake of the gable by simply connecting its upper and lower end points. Draw a vertical vanishing trace through the left vanishing point on the horizon line. Extend the rake of the gable to meet the vertical trace. This is the vanishing point for the rake and all sloping lines parallel to it. To establish the rear rake of the gable, extend the line from this vanishing point through the rear peak of the gable. The general procedure for constructing a linear perspective is to find the perspective length and location of major vertical lines, and then draw the planes and volumes the lines establish by following the principles of convergence. As a general rule, work from points to lines to planes to volumes, and first establish the perspective of the major forms of the subject before working out the secondary forms.